Let's do a few examples with two elements. So I have potassium and I have neon. The very first thing we need to do is find the number of electrons, because that is what we're showing in these numbers. So the number of electrons is usually the atomic number, but not always. So be careful there. For right now, it's our atomic number. So for potassium, our atomic number is 19. So let's write out the electron configuration. I need 19 electrons in this atom. So if I look at my chart, my filling order, I start up here, 1s. So I start writing 1s. And how many electrons can be in each orbital? Using our rules, the first one, actually the second one, the Pauli exclusion principle, I know it's 2. 2 electrons down. 17 more to go. Next on my list is 2s. 2s. I can also fit 2 electrons there. Now is when it gets a little tricky. Next is 2p. 2p, however, remember our p orbital, we have a few types. We have 3 types. So this number here can be 6, because 2 times 3 is 6, and all of them are filled. So I have 6 electrons here. Next up is 3s. How many electrons? 2 in our s. Next up, 3p. And now I got to check. How many electrons am I at? Well, I have 1 is 2, so 2 plus 2 plus 6 is 10. Plus 2 is 12. I have 7 electrons left, so I can fill this up with 6. And then my last one is 4s. Oh, it's in column 1, so that last number has to be 1. I have 1 electron there. That's it. I'm done. That's my electron configuration for potassium. Let me do one more now, but for neon. So neon's atomic number is 10, which is a little easier. And I start with 1s. And I can do it differently this time. I'll write out my energy levels first. 1s, 2s, 2p, 3s, 3p. Let's go that far. Let's see how far we need to go. So I have 1s2, 2s2, because it's filled, and 2p, 6 is the most. Am I at 10? 2 plus 2 plus 6 is 10. So I actually don't need these other ones right here. 2p, 6. And I'm done. That's it. That's the electron configuration for potassium and neon.